Hello Year 12 and welcome to the first of our videos on logarithms. The first of these videos is a review of these log laws that we learnt last year. Right. So you need to remember here that that this sort of expression here, y equals log base a of x, or the log of x to the base a, is the same as saying that x is equal to a to the power of y. Sort of like, for this base, what power will give me this number? Right, the answer to that is y here. So, we are going to use quite a few sort of log laws here, I suppose, to evaluate these. We could use our calculator. It's base 10 now. Calculator will calculate log base 10s for us, but I'm going to rewrite this as, right, the log to the base 10 of 10 to the power of 3. My log laws tell me that's the same as 3 times the log to the base 10 of 10, right? I can bring that power out the front, and the log of any number to the same base is equal to 1, so that's equal to 3, right? And that's showing that 10 to the power of 3, right? 10, our base, to the power of 3 equals 1000, right? That's how that works. Now again, we can do that with numbers that are smaller than the base. So this is the same as the log of to the base 2 of 2 to the negative, right, 2 to the negative 4, which is negative 4 times the log base 2 of 2, which is equal to negative 4 times 1 is negative 4. Now, I can do log base 10 on my calculator. I can't do log base 2, but we can use the change of base formula. Flip side to this though, while it might be hard to punch that into my calculator and get the answer, it's really quite easy to check my answer, because if I type in 2 to the power of negative 4 in my calculator, I really should get 1 over 16. Now, here it's going to ask us to use our calculator to do this. So if I take the log base 10 of both sides, I get x equals the log base 10 of 850. And I pull out my trusty calculator. Ooh, here we go, new calculator. Make sure everything's clear there, and I use the log button right here. That means base 10 of my calculator, log base 10 of 850. And I get 2.9, what do I want, 4 significant figures? 2.929. 929. Okay, now this, back to the calculator, clear that away. Now the log of 0.07 equals negative 1.155. What was it? 1.155. Righto? So we can evaluate those things. We can solve, fairly straightforward equations there. Moving on, we've got to do a bit of explanation here. Why is the log of this number, whatever it is, somewhere between 4 and 5? Well, 10 to the power of 4 is 10,000. 10 to the power of 5 is 100,000. And the number 12,345 is greater than 10,000. but less than 100,000. Now if I take the log base 10 of all of those things, I get the log of this is, log base 10 of this is 4 is less than the log base 10 of 1, 2, 3, 4, 5. Okay, I took the logs of everything there. Fair enough. Now, we need to have a bit of an understanding of the graph of these things. Right, now, we have talked about domain lots of times before, and I think I tend to stress that there are two things to watch out for when calculating the domain. Two rules that we can't break in mathematics. Can't divide by 0, can't take the square root of a negative number. I am now going to introduce a third one for you to remember, is that you can't take the log of a number less than or equal to 0. Right? So there is a restriction on the domain for the function y equals log of x, and that is x is greater than or equal to 0. Right? It is a reflection of the exponential y equals 2 to the x, right? Log, or whatever that base is, about the line y equals x. Righto? So generally we get this sort of thing here. I know that if y is equal to 0, then the log of x is equal to 0. That means that my base raised to the power of 0 is equal to x. Something raised to the power of 0 is equal to 1. So, in a straightforward sense, whatever the base is, here we always get that intercept at 1. Right, just the same as we do for an exponential, crosses the y-axis here at 1 in its most straightforward form. Rightio? So, we can push on now to some more complicated things. That we know these sort of identities. They're reciprocal or inverse functions. They are the inverse of each other. So the log of e to the x is x, and e to the log of x equals x. And they're really sort of helpful things later on, right at the very end of this unit of work. We'll rely on those things again. Okay, but we use these properties to solve some equations. Right. So, remembering our log laws here, we need to express these things in a way that we can solve them. So I'm going to rewrite this as equals the log base 7 of 7 minus the log base 7 of x to the negative 1, right, 1 over x. Now, log base 7 of 7 is 1. Now this is the same as the negative, I can pull that negative 1 over here, is equal to 1 plus the log base 7 of x. Right here, that negative 1 comes out the front and cancels out the negative. So the log base 7 of 7 over x is 1 plus the log of x. Over here, well, we need to be a little bit careful. That squared there doesn't apply to the 5, so we're going to get things in the right order here. But I'm going to say this is the same as the log base 3 of 5 plus the log base 3 of x squared. Okay. Log base 3 of 5 isn't going anywhere, but I could say that this is the log base 3 of 5, that's some constant, and this is plus 2 times the log base 3 of x. Okay, there's our solution there. Well, it's not a solution, but we've expanded it out. We've written it in another form. All good? Now, change the base formula. Remember this, right? It's helpful at times that the log of the number divided by the log of the base. Right, we'll change that for you. So, we cannot punch log of 3 into my log base 3 into my calculator, but I could rewrite this as x is also equal to, I'm going to use the log, a natural log here. So I'm going to say natural log of 100 over the natural log of 3, and then out comes the calculator because I can calculate those things. Clear that off. Log of 100, oop, that's 10, that's 100, equals divided by the log of 3 is for significant figures 4.192. 4.192. Okay, and I can check that. 3 to the power of 4.192. Right, let's grab the calculator just to reassure ourselves. 3 to the power of 4.192 equals pretty close to 100. Okay. Right, that's how we can sort of reassure ourselves we've got those things right. Now, what we're going to do here, 2 to the x equals 80. Well, if I take the log base 2 of both sides, I'm going to say for x, right, because I take the log base 2 of that, is the log base 2 of 80. Right, that's how I can sort of undo that exponential function. That's really helpful. We've been dealing with exponentials. Now, all of a sudden, we can reduce those. Well, from an exponential to a log, but anyhow. Now, log base 2 of 80 is still a little bit of a problem, but that's equal to the natural log of 80 over the natural log of 2. And again, out comes the calculator. Log of 80 equals divided by the log of 2. And I get 6.322. 6.322. Now, 2 to the power of 6.322 should be 80. Yeah, all good. Wonderful. Well, that's the first of these videos. I hope it's illuminating. It should be revision. Handy things to do. Jot down some questions, ask me in class.